Hi everybody. So in this video, I'm going to show you how we can sketch modulus functions. I'll introduce you to the idea in example 1, and in the following examples, we'll try some exam style questions. So in example 1, we've been given the function x plus 1, and we need to sketch the modulus of this function. So we'll use these table of results. When x is negative 3, we'll substitute that into here, and we get negative 2. But the modulus of that negative 2 would make it positive 2. When x is negative 2, we substitute that in and we get negative 1. When we take the modulus of that, we get positive 1. So what do you think will go here? Can you see a pattern? Yeah, so when x is negative 1, we get 0 here, and the modulus of 0 is 0. When x is 0, we get 1 here, and that has a modulus of 1. So you can see we're just increasing by 1 every time. And if we plot these points on the grid, we've got negative 3 and 2, negative 2 and 1, and we'll plot the rest of them. So to sketch a modulus function of this, all we need to do is join these together. So this is a sketch of the modulus of f of x. Now can you see that these points are a reflection of these points in the x-axis? And this is a defining property when you find the modulus of any function. The modulus of f of x will always be a reflection in the x-axis. These points are all reflected onto themselves, and these points are reflected through the axis to create these points, okay? And if we look at the function of the modulus of x, well, this is where we take the modulus of the x values, not the function. So if we take the modulus of negative 3, we get positive 3, and then we get 3 add the 1 to make the 4. If we take the modulus of negative 2, we get positive 2, and then this becomes 2 add 1 is 3. What do you think the next few points will be? So when we take the modulus of negative 1, we get positive 1, and 1 add 1 is 2. When x is 0, we just get 1. And when x is 1, this is already positive, so we just substitute this into here, and we get 2, and then 3, and 4. And now we can plot these points. So negative 3 and 4, negative 2 and positive 3, and we'll plot the rest of them, and then we'll sketch the graph. So if the modulus of f of x is a reflection in the x-axis, what do you think the function of a modulus of x will be? So the function of a modulus of x, this is a reflection in the y-axis. Can you see that all of these points have been reflected through the y-axis to create these points, okay? So as we progress through this video, we're going to be using these two properties. Let's try example 2. Okay, so we've been asked to sketch the modulus of x plus 3. We start by sketching x, and we know this will be a diagonal line that passes through the origin. And because we're looking at the modulus of x, this will be a reflection in the y-axis. So all of these points become positive. I'll label this as the modulus of x. And then all we need to do is translate this 3 units up. So this vertex was at the origin, and now we're going to translate it up to positive 3. Okay? So it's a good idea to always start with the x term, and then to apply each transformation one term at a time. So this is the modulus of x plus 3. For example 3, if I sketch a pair of axes, we'll begin with plotting negative x. And again, this will be a diagonal line passing through the origin with a negative gradient. And then we need to translate this positive 3 units. So we've got negative x plus 3. And I'll show the intercept. The next thing to do is to take the modulus of this green line, which means these points will remain positive, but these points will be reflected through the x-axis to here. So we've got the modulus of 3 minus x, and the point on the x-axis will be when the modulus of 3 minus x equals 0. So this is when x equals 3. So I'll label that here. Now we need to compress this by a scale factor of 2. So this intercept will be doubled to positive 6. And then for the addition of 5, we just need to move it up 5 units. So if I copy this and just move it up by 5 units, it will go about here. And this point will have a value of y equals 5. So this is the sketch of a graph f of x. For part B, to state the range of this function, well, the range considers the y values, and you can see the minimum y value is at positive 5. So for part B, the range, this is when f of x is going to be greater than or equal to a positive 5. Okay? Let's try example 4. So in example 4, we've been asked to sketch the graph of modulus of a minus 2x, where a is a positive constant. So do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. If we begin with a negative 2x, this will have a negative gradient of 2, and it will pass through the origin. So this is y equals negative 2x. And then we're adding a to the negative 2x, so this will translate this line upwards by a units. So we'll copy the graph and we'll just translate it upwards. So we'll have a y-intercept of positive a. And this coordinate will be when negative 2x plus a will equal 0. So a will equal 2x, x will equal a over 2. A over 2. And then we need to take the modulus of this function. So this means where the line goes under the x-axis needs negative values are reflected through the x-axis to become positive. So this will be a sketch of y, okay? And we can see the coordinates on the axis will be at 0a and a over 2, 0. Okay? How did you get on with that? Let's try example 5. So now we need to find a modulus of this quadratic. Do you want to begin by plotting the quadratic on a pair of axes, and then thinking about which parts cannot be negative, and then reflecting them? You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back if you had a go. So the first thing that we need to do is to sketch this quadratic. And to do that, we can find the roots by factorizing. So if we let y equal 10 minus 3x minus x squared, then we can factorize this into 2 minus x multiplied by x plus 5. So our roots will be at positive 2 and negative 5. But remember that we've got a negative x squared, so this will look like a U shape. So now we've sketched the quadratic, we need to sketch the modulus function. So because we've got the modulus of a function, we're going to reflect it in the x-axis. So in these parts, when x is less than a negative 5 or greater than a positive 2, these will be reflected through the x-axis to here and here. And then the points between negative 5 and 2 are already positive, so they will remain positive. Okay? So this is the sketch of f of x. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.